Welcome to today's Advanced Manufacturing Media webinar. Our topic is Electrodes Made Really Easy. Hi, I'm Jim Sawyer, Executive Editor of Manufacturing Engineering Magazine, which is part of SME's Advanced Manufacturing Media Group. Before we begin, I'd like to provide some background on what we will be doing today. Our sponsor, Cimatron E, is a leading developer of CAD/CAM software with more than 30 years' experience in providing manufacturing programming solutions. It is part of 3D Systems, which provides 3D printing-centric design-to-manufacturing solutions, including 3D printers, print materials, and cloud-sourced on-demand custom parts. You will be able to ask questions during the presentation using the Q&A box that appears at the right side of your screen. If time runs out before we can get to all the questions, we will make sure the answers are emailed to you. Now, let me ask you a question. Do you like to design electrodes? Okay, I think we all know the answer to that one. But electrodes are necessary, and we all want to design them as efficiently and quickly as possible. And helping you do that is our goal today. Now, portions of this webinar will include screen sharing, and as often happens over the internet, the quality of the presentation can be affected by the type of internet connection you have, the total bandwidth available to you, and the number of people accessing that bandwidth at the time. Mobile users will not be able to view the screen sharing during this live presentation, but they will be able to hear the audio portion. An archived version of the webinar, viewable no matter what device you are using, including the screen sharing, will be available later today. If you experience any difficulty seeing or hearing this live presentation, please let us know via the Q&A app. Also, if you have any questions about any other aspects of our webinars, please email me at jsawyer@sme.org. John Barnes, our presenter, is Technical Sales Account Manager for Cimatron E. John has more than 20 years of combined experience in tooling and aerospace. While most of his time was in the tooling industry, he played an integral role in manufacturing the Themis telescope that surveyed Mars for the presence of water in 2001. While working for Cimatron, John has served many roles, including technical support, applications engineer, training, and sales. Now, here is John Barnes.
Thank you, Jim. So today's topic is about electrodes, and I know I have a lot of Cimatron customers in this group, and I'm kind of dividing this up into two different topics where we're going to look at the electrodes that are really easy and go super fast, and some electrodes maybe that aren't quite so easy and will take a little bit longer. So if you see some familiar things in the beginning, please don't bail out on me. I've got some newer stuff right behind it. So as Jim said, Cimatron is now part of 3D Systems. 3D Systems was a pioneer in 3D printing, and we're pretty excited to have their backing, and they're really committed to having a thorough product line for everything manufacturing, from software to scanning to printing, and we want to cover all the bases. Yeah, and here you can see that all the things that we're looking at: production, machining, inspecting, scanning, product design, tool design, and 3D printing. And we want to have an integrated approach to all of these things, which I think is really important. So for those of you who haven't heard of Cimatron, we are a CAD/CAM software. We do both design and machining. I would say that we specialize in mold design and die design, and we have really great NC, and we have some wizards for electrodes and for mold design specifically. And we've had a lot of research and surveys done that have shown that the customers that use Cimatron are able to shorten the delivery time. Okay, so now we're going to look at the software. Okay, so I'm going to start in our Electrode Wizard, and I'm going to take a core block, and this is going to create a new folder to keep everything organized. And the first thing we want to care about is the coordinate system. We want the UCS, the user coordinate system, probably to be in the center of the block, maybe at the highest point. But sometimes the touch-off might be down here at the parting line. And I just want to quickly demonstrate how that can be done easily. If we do a coordinate system by center of geometry, we can pick a few things, or we could pick everything. And when we middle click, we get a bounding box of whatever we included, so that we could quickly get to the center of that geometry if the pickup for the electrodes were going to be at the parting line. So let me just show you. If I pick up here, then of course that changes the bounding box and we could be at that level. So it's a real nice tool. Sometimes it's not always that easy to get to the high point in the center. We've got nice tools to accomplish that. So I'm going to just dive right in here and start extracting some electrodes. And again, for those of you that have seen this demo before, I won't spend a lot of time on it. I'll just go through it pretty quick. So this is the area that I want to burn, and I can do a fit and center. And now I'm centered on that geometry, and the amount of overhang that I have is a preference that I can set so that it's always going to be the same. I'm not going to use a template on this first one. And we'll go ahead and extract this one. Okay, and of course this assembly has been built for me automatically. That's what the wizard does for me. Now I'm going to activate that file and put the blank on it. And here again, all these numbers should be kind of set up in the preferences so we don't have to change any of this stuff. I'm just going to say OK. Then we're going to do an auto contour. That finds its way around the opening. And we can do an extension. And this is what I was calling a skirt. And we'll get into that in the next part. Right now I'm just going to do tangent all the way to the blank. And obviously whatever draft angle I have on each wall is going to be continued all the way down to the blank. Then we're going to give it the coordinate system, and we'll throw a holder on it. Okay, and now we're going to save this as a template. So we go to Electrode, save as template. Alright, and then we're going to go back to the main assembly. And we'll now extract this area. Do the fit and center. Apply the same template. Okay, and so it repeated the same steps over here that we had over there. But obviously, with this geometry being so similar, it shouldn't be that impressive that it can repeat those same steps. So let's do it over here in an area where the geometry is different. We're breaking out inside of the block. We'll go to the top and extract the electrode. Compass that area. Do a fit and center. And do it. Okay, so over here, it gave me the same extension in the Z direction that we got on this side, but it also came out this way because tangent to blank includes this wall. So these guys came out to meet that wall and give us a nice electrode. So I'm going to go through here and just extract a few more really quick because I want to get through this part fast. I've got some other nice things to show. So I just want to show you, on a good day when the geometry is relatively simple, this is what we can expect to happen. I'm just going to go around and create a bunch of trodes. You'll notice that I'm right-clicking and staying in the feature. And these ones will take a few more of these ribs. And this one is kind of challenging to pick the surfaces that I want. One little trick that I'll do is I'll put the electrode way over here where it's not picking anything. And then I'll do a right to left box pick, which will pick up only what I care about. And then that same fit and center will put me right on location. And this will be the last one that we do, and this one. Don't want those. Okay, so we made some electrodes, and these all have the extensions on them, but this one only has one extension, and it's because the template that we saved only had one. So let's activate this electrode, and we will do apply template from a neighbor. We select a neighbor, and the steps are repeated, but obviously it's not putting on a holder again or giving it a second blank or anything like that. It's smart enough to skip what it knows has been done. Okay, so that was nice. Also, I had asked for, I think, 200 thousandths of clearance between the burn face and the blank, and all of these probably have 200 thousandths, but this one has a lot more. Let me show you that the distance from the burn face to the blank is greater because it knows that the block is in the way and it doesn't want to bump into that. So it's going to take into account any surrounding geometry and not hit anything. All right, so let's look at this one, and I want to explain now what I mean about hybrid modeling. So for this electrode, obviously we would never design an electrode like this because it defeats the purpose. We got sharp walls and stuff here. But I do it this way in order to explain how the software works. So Cimatron, being a hybrid modeler, it sees, well, when it extracts the burn faces, these blue faces are stitched together. So this is a solid, but it's not a closed, watertight solid. It's just an open solid. Some people call it like a sheet body. And when I put the extensions on it, each one of these are individual surfaces, but they're also individual bodies, which is a little bit hard to think of sometimes, but I can stitch these together. Okay, and now this is one body, but it's still open. And I want to hide everything else and show you that if I were to show the open edges on this, you'll see that this whole bottom here is all open. And even though it's open, we can do some things like maybe remove and extend and pull that round off, for instance, or take these rounds off. So we can perform solid operations even when the solid body isn't closed. Okay, let's now go back, and I'm going to merge this onto the blank. Okay, and now this is one solid electrode, you know, like you might have in other systems. And in fact, let me do this. I'm going to create a copy of this. We're going to say add location, and we're going to put another one of these electrodes on top of this one. Whoops, got to call it different. Do that again. Different component. Okay, so let's hide this one for a second. And let's say that for this one, we want to get rid of that center area. So we could do a solid, remove and extend, and we could make this center boss go away. And then on the other side, with this one, we could get rid of the ribs and keep the boss if we weren't going to cut it. We also could do like a solid, extend, and just reduce the diameter, keeping it a little more rigid. And if someone else is going to be programming this, we might want to steer them in the right direction as to what size cutters need to go in there, right? So we could do a round, and again, just kind of box pick in here, get all these, and we'll make it 65 so that they know what kind of cutter has to go in there to clean that out. So that's why it's a hybrid system, because we have solids and we have surfacing, and it's kind of a blurry line between the two. And you're going to see some even cooler stuff here when we get to the next part. Well, I want to make some drawings right now because we have quite a few electrodes here. Now would be a good time to show the automated drawings. All right, and the first thing we'll do is we'll make a burn map drawing. Okay, so this is a burn map. It gives me an isometric view of all the electrodes that we just made, and tells you the location where they're going, if there's a rotation value. And here it shows you, which electrode goes where. And I used to really like this table that it puts out. I used to do a plot by box, and I would print this out on an 8.5 by 11 piece of paper for the guy who has the tedious job of punching in all these coordinates. But that even kind of went away now because we have the ability to post and create a program and send it directly to the EDM. And we're going to go over that a little bit too. And we can also do individual drawings. Create one individual drawing. And by the way, I could say create all the drawings. I can go get a cup of coffee and come back and have all the drawings made for me. Of course, they might require a little bit of tweaking to them, but it wouldn't take much for sure. So let's have a look at the individual drawing. And you got a top view, front view, side view, ISO, and it shows me the blank size. So the guy who's doing the saw cutting knows real quickly what those blanks have to be cut up as. And there's also a burn drawing. So this would give you a view of that electrode in the front view. Again, you got a chart for where it's going. And we can even add hidden line attributes to it. I always like to show this as well. So here, I'm going to ask that the core have hidden lines, and they can be a dash gray color. And I will ask that the electrode has a solid, thick red line, just so it really jumps out as to what's being done underneath there, and the trode's orientated the right way. Here's the slot in the Corolla holder. And that can actually be part of the template too. I just don't have it set that way currently. Okay, so let's close these. And let's look at a trajectory. I think some of these things, I'll show the core block and one of these side guys over here. So maybe we decide that this electrode would be more efficient to burn in the X rather than the Z. We can go to a 3D trajectory and pick this, and we'll look like that. And go up in Z. Okay. So that quickly we can build a 3D trajectory in order to do a side burn. And let's go ahead and send one of these guys to NC. Okay, and I'm going to apply a template. And this may come across looking like automatic programming, but it's not automatic programming. I prefer to call it automated programming. The difference being that it's my own machining strategies being driven by color. So what I'm asking is that the stock be a representation of a 3D bounding box of the purple, the green, and the blue. And then I want to rough that volume down to the purple. And then I want to finish the blue and the green down to the purple. And if picking is required, I don't need the small tools to go all the way down to the purple. Once I get past the tangent point, I can mathematically determine how far past to go according to tool size and formulas and things like that. So I'm going to hit execute, and this will take off, but it's not the software, knowing what to do. It's me knowing what to do and driving it according to my standards and color and, years of experience. Okay, so this one is done, and let's look at what it did. First of all, we have a stock, and again, that was just a bounding box, nothing special there. I did have it start up high. Okay, then we're going to do a roughing procedure with a 1/2-inch tool. You can look at what that looks like. In fact, pretty much all my electrode templates stay further away in the wall offset versus the Z. So I'll get pretty close in the Z, but I'll stay like a millimeter away in the wall to keep rigidity in the rib trode, because I don't know if it's going to be 30 thousandths wide or 3 inches wide. Okay, and then next I have a horizontal procedure that just establishes the floor. Change the color of that so we can see it. Okay, that's the floor milling. Then we have the top being cut. And, something's wrong here. Yeah, so that's not right. I have to turn one thing off. This particular template should not have been recutting the top. Need to calculate that. Okay, yeah, so what we want is we want the tool to start nice and deep on account of being a ball cutter. There's no point starting at the top. And it's going to run around there and finish the walls doing a constant helical motion all the way down. So it's ramping the whole time, no transition between layers, all that good stuff. Okay, and then we have the remachine. Now, this remachine is only calculated and used if it needs it. You'll see I have 2 light bulbs here, and I have 2 more procedures that don't have light bulbs. And that's because once the stock is picked out, it knows that the electrode is picked out and it doesn't give me those paths. And I'm going to demonstrate that a little bit better here in a second. And let me just see if I have multiple cutters being used here. And I do not, because that's a standard length. Okay, so let's do a couple things. I'm going to switch over to the CAD side, and we're going to stitch this just like we did earlier. And I'm going to do a extend. We're going to push this wall up, say a 1/2 inch. Okay, and then we're going to go back and recalculate this. Execute. And what I'm trying to show is that the software is capable of having multiple length tools. And so for this area right here that's being picked out, it can use a standard length cutter as deep as it can, switch over to a longer cutter if necessary. This one shows it. Yeah, so this one took it, but it's so far at the bottom that it's probably not worth using. Let's look at the next one. That one did not take it. Why? I'm not sure why I didn't take that other tool. Being in a webinar, I don't have time to troubleshoot it, but it does work. I'm just not sure what I have wrong there for it to not happen. But let's do one more thing. I'm going to go back to the cab side, and I'm going to get rid of this picking altogether. We'll do a solid remove and extend. We'll take this little L shape out. And let's go a little bit taller again. Okay, go back to the cam side and recalculate. We haven't talked about overburn either. So the overburn is going to be handled in the NC, and I have one place where I can plug it in, and it will change the values in all the procedures. Okay, let's look at this finished procedure. So here we can kind of see by the darker color that the longer tool comes in at this point, and it has a lesser down step, slower feed rate, slower RPM, but it's all handled by the software. It just takes longer tools, whatever necessary, and it's only going to do picking where picking is necessary. So you can see how the template is flexible. You either work with short electrodes, tall electrodes, whether it needs picking or doesn't need picking. It's a very flexible type of automated programming. So currently, the spark gap that I have is 7 thousandths, and I could change that to say 10 thousandths, and it will push that value into all these guys, and then I can recalculate. Or I could take this whole toolpath and do a copy and paste, and I could call this the rougher and this the finisher, and the roughers might be at 10 thou, and the finisher could be at 5. So it's real quick and easy to have different overburn amounts based on roughers and finishers. Okay, so now let's get into the other job. Oh, wait a minute, I forgot to show the EDM setup. This will have to be quick because we're using up a lot of time here. So for the EDM setup, all we do is click here, and we're going to choose the appropriate machine. We have a lot of machines here. These are all custom machines. And so for the AGI, for instance, we set the material, number of work pieces, quality target, satisfy all this information. Then we're going to look at the electrode itself, and there's different types of electrode shapes that the AGI is looking for. We could say we have 3 roughers and 1 finisher. You can set the orbit type to be 2D or 3D. And then of course the overburn. So this one would be 10, this one would be 5. And then here's the location. And we would have the ability to stay up maybe 5 or 10 thousandths. If you wanted to burn these overnight and have all the electrodes up 5 or 10 thou, there will be a parameter that will enable that. Here's information about the electrode. And then basically we just say, okay, we want to create a program for all these guys. You can do them individually or everything. You can change the order around, obviously. You want to burn number 8 first, you just put it at the top. And then you create the program. And then, of course, you just load that into the controller. Okay, so let me get out of this job and open the other one up. Okay, so this is kind of a more complex job where the electrodes are going to be breaking out on a side wall, and let's just jump into it. Go to the top view, extract electrode, and let's say we're going to do this one first. Okay, so one nice tool that we have here is called Visible Faces Only, and I can box pick across here. I only get the faces that are visible from my view perspective. So if there were water lines under that or the bottom of the block, box pick doesn't pick anything beneath. Okay, so there's the surfaces that I want, and we're going to do a quick setting of the angle. So we can choose reference line. That puts it in the right angle. Maybe we want to round it off to -20. That'd be such a bastard number. And then we do a fit and center. Okay, and then we're not going to, I'll apply a template because we're in a hurry. The template we're going to use is just a, a blank and a coordinate system. Okay, so now here's the electrode, and let's again do a copy and paste of that. Duplicate component. And what I want to point out is this, that there's a lot of solid-based systems out there that can do the electrodes almost as fast as I did previously in the last job when things are simple, right? But when things aren't so simple, this can be a lot more challenging. So let's have a look at this one. And I'm going to do a solid new extrude. And we'll push this down there. Okay, and let's do a cut of this solid against this workpiece. And this is really, really bad geometry. There's a lot of imperfections in this model that I had to work with, and I thought it was good to leave them there, and I'll show some of them if we have time. Okay, so my blue faces are still there. Let me get rid of those. Okay, so just doing a Boolean cut against that area is going to give you a result like this. And a lot of solid packages work this way. You stick the electrode down in there and you do a cut, and you end up with this result, and you have a lot of work to do to clear all this, right? Where the way that we're doing it in Cimatron is different. We're only taking what we need, and we're just going to expand on it from there. And I want to show a couple things that I think were pretty cool. The first thing is that I can do something similar if I do a solid new extrude and take this face and go up to here. Okay, and then I do a cut. This is actually something relatively new in our latest versions. I can pick these surfaces last time. Okay. Let me do this. I'll hide this one for a second. I'll do a flip of the screen. And when I cut this, do a flip against these. And get it going the right way. Ah, there we go. The extend was turned off. That's what I'm looking for. So we can do a cut like that and just focus on those surfaces. And I think it's a lot less work than having to do it with the other way where you have to remove all that stuff individually. Well, let's look at another option still. And I want to clean this up just a little bit. Let me draw a couple lines here. This is another little trick I've been doing where if you sacrifice some of these ends, it goes a long ways to make things nicer. So we're going to trim this against that, going up in the Z. Okay, and now I have nice clean edges to work with, and we could do the auto contour and then extension, template, and let's go like 100,000. Okay, and then we can turn on the block, obviously. We can look and see, is that giving me enough extension to get outside what I care about? It's actually burning. And that looks okay. And we could clean it up a little bit, make it better, but I'm really running out of time here, so I'm going to be a little bit sloppy and just take it right to NC. Let's save it, and let's go to NC. Okay, and now we're going to apply a template. This will be the shape top. And again, everything's going to be driven by color, so I should be able just to hit execute. And what's going to be interesting is that the rougher is cutting everything down to the purple, like we would expect, but the finisher is doing something a little bit different. It's only going to machine the blue and the green, and it's not going to waterfall. Not waterfalling was something that we worked on a lot and kind of finally perfected. And so it does two things. It's going to spend less time on the machine because you're not cutting everywhere that's not important, but it's also going to leave it rigid. So let's look at the result after that one runs. You know, here's your model, and you've kept rigidity down here outside of the block where it doesn't matter, and you've only spent time finishing what's really important. And if we want, we could even bring this back into the CAD model and make sure that we're not violating anywhere. In fact, let's do that real quick. So we would take this, machine simulator, let's do standard because I want to have nice quality. We don't need to look at the part. Set the tolerance to like 2/10. Run fast. And by the way, this is going to be a top-down approach. It's going to do the walls down to the bottom of the floor, catch the floor up, and then go back to doing the walls. Okay, so there's the electrode. We didn't have to model any of this fancy stuff in the back. We kind of got it for free. And now we're going to save it. All right, we'll close this. Close this. And then here we will import it. Okay, and then we can look at it against the block and just make sure that we didn't violate anywhere. I know I didn't, but if you're doing this for the first few times, you might want to double check yourself to be sure. And then the last thing I want to show is that same idea with more electrodes. This one. Okay, so here I did kind of the same thing, and I ganged up a bunch of these electrodes, and it's basically all these areas. And this one has got little extensions on it already. So I'm going to throw a template at this, and we'll see how it behaves. Okay, calculate. And again, the top-down approach is really important because if you don't do it that way, you'll break electrodes. Probably if anyone's accustomed to machine thin trodes, you know that a lot of times you have to boundary regions off and say, only go here first and then go over here and then go over there. There's so much work involved in telling the cutter where to be and where not to be that the programming time can be pretty intense. And this is the first, since we got this ability with the top-down approach, it's the first time I've been able to apply templates to this type of work and really have it, not break electrodes. Okay, so here after the rougher runs, we have this result. And again, I'm keeping a lot of stock around the ribs so it stays nice and rigid. And when this one calculates, you'll see that, it's only going to machine the areas that are important and not waterfall all the way down again. So this was the point of the webinar, really, is that I think that sometimes we get carried away and caring too much about how beautiful the models are, and putting the extensions all the way down to the floor, and we can make more work for ourselves by having to cut all that stuff when it really isn't that important. As long as you're careful to give yourself enough extension, or skirt as I call it, the cutter should go everywhere that it needs to, and spend a lot less time both designing and programming and machining the electrodes. It's almost done. There we go. And let me just position the tool there so you can see that, the tool is going as deep as it needs to go. And I like using ball cutters. I mean, you don't have to use a ball cutter here, but I think it's nice. And the other thing I didn't mention was that all of these lace cuts across the top are all orientated according to each rib. That's something that's automatic in the software. It's able to pick the angle according to the longest direction. And again, all the floors are going to get done first while the short is rigid, for it to not break any. Okay, I'm going to turn it back over to Jim.
Thank you, John. That was really a lot of step and time savings that you showed us there. I was particularly impressed with the rich visual environment that helped illustrate exactly what was being done. We do have some questions here. I know that we're virtually at the top of the hour. If you can stay with us, please do so. We do not have a hard stop right at 3 o'clock here Eastern Time. If you do have to go, this whole presentation will be available in about an hour. You can access it using the same link by which you joined us this afternoon. So you can look at this again, and you can share this with your colleagues. And we do have questions, as I said. So here is one. John, can you output STL files directly from NC without using simulation?
I think so. Let me see. Yes. Yep.
Yes. So that is.
Yep. Yeah, that's a Cimatron customer. I'll just tell them you right-click on remaining stock at the procedure, and then there's a save file option. And I don't know if that would be better or worse quality than what we got from the machine simulator. It probably would be a better quality, I would think. So it's actually a pretty good suggestion. I might check into that.
Okay. Let me see here. Let's get another one. When you changed the overburn, how did that change in procedures?
Well, it's a common parameter. So it depends on what's highlighted in Cimatron. If the toolpath folder is highlighted and you change the spark gap, it pushes that parameter into all the procedures. If the procedure is highlighted and you click on Edit Spark Gap, it's only going to affect that one procedure. So I guess the the key is to have the toolpath folder highlighted when you use that function.
Okay. And someone asks, is there a webinar about how to set up and use the automated tool paths?
I don't know. I mean, I'm sure that my email address is going to be in here at some point. Maybe it is now. But if anybody emails me, I do have some personal training videos that I give out. I don't know if I have one. I probably have one on that, but I don't have one. I don't know of any currently, like in our official webinar recordings.
All right.
But I'm happy to help. You guys email me. I'll give you what I have and help you out.
Okay. Next up, what types of CAD files can Cimatron read?
Okay, so what comes standard with the software would be, all the neutral formats like IGES and STEP, Parasolid, DXF, DWG, and then we also support direct translators at additional costs such as SolidWorks, NX, Creo, CATIA, Inventor.
Okay. And let's move on here to another one, and that is, how much training is required to learn the electrode design, also the NC?
That's a good question. I think it depends on how familiar the user would be with assemblies and solids. For example, if somebody is currently using SolidWorks and they understand assemblies and solids, I think that cuts down on the learning curve quite a bit. We offer a 5-day class at our facility in Novi, Michigan that will probably be too much really to learn the electrodes. I mean, it's kind of an introductory class to learn Cimatron, and I would say that anybody who is able to use Cimatron could probably learn the Electrode Wizard, in a matter of hours. So the Electrode Wizard itself is really quite simple. As you saw, it creates the assembly structure all on its own. It's kind of drag and drop. We also offer web-based training and on-site training, but for sure the electrodes is the easiest piece of the software to learn, and often it's the module that we kind of get our foot in the door with, because everybody hates doing electrodes. It's a struggle to get them done and get them done quickly, and you can buy Cimatron just for that purpose, but normally what happens is that once they start using it, it starts creeping into other departments because it's so loved.
All right. Another one here. How do you input the electrode position from the tool changer into the program for the EDM using the automated system?
I don't quite understand the question, but I think it would require a manual interaction in the EDM setup that would be part of the customization. And I should elaborate on that a little bit, that the EDM setup interaction and the post is kind of all customized. It's not really sold out of the box. It's a lot like buying a 5-axis post processor. Each machine can be different and require different things. So the EDM setup isn't something that you give us a PO for and we give it to you tomorrow. It's something that goes into the queue to be worked on, and it's very, very customized.
All right. If that was a sufficient answer for the questioner, That's great. If not, and you're still on the line, please get back to us and explain what you need, and we'll try to address that. But for now, the question is the overburn accessible as a parameter for controlling Z depth?
I don't know. That would be better answered by somebody. We'll find out. We'll get back to you, but I'm honestly not sure.
Okay. And moving on, why do you prefer to put your electrode UCS on the tip of the trode instead of the base of the electrode holder? What benefits do you see with your strategy?
That's an excellent question. My answer would be that I don't. I think that the electrode UCS should be on the back of the holder because it's common, for every electrode. However, when I program and I use templates, I do like my NC coordinate system to be the top of the electrode because a good example would be the clearance plane. If I always want to have a 1/4 inch or a 1/2 inch clearance plane, that only works when I'm working off of the top of the electrode. And in a recent version, I don't know if it was 11, we're at 12 now obviously, but a version or two ago, they gave us another automatic option. So we have an electrode UCS and an NC UCS so that they don't have to be the same. You can have the electrode UCS can go to the bottom of the puck and the NC UCS can go to the top of the trode, but it doesn't necessarily mean that you have to pick up the top of the trode when you are going to machine it. I can program to the top of the trode, and then I can post from the bottom of the puck. So I'm right there with you on not having to change all these things. So the way that you're doing it is the right way.
Okay. Here's a fairly simple question. What EDM machines are supported for posting?
Yeah, that's a good question. I don't know which ones aren't. I mean, most of the popular ones, Makino, Mitsubishi, Sodic, Agi, Charmy. I would say, I hesitate to say all, but I think all, or at least most.
Okay. So it would be fair to say far more are supported than are not.
For sure. Yeah, as long as it's networked and you can access the network, then probably we can do it.
Okay. We'll take a few more here as our time is running down. Can the automated drawings be customized to match our current documentation?
Yeah, the automated drawings are just a template, so it can be rebuilt to look any way that you want. In fact, my template had 2 pages. It had an inspection drawing and a burn drawing. I think is a bit more rare. I think most customers probably use a single page electrode drawing. So yeah, it's very, very customizable, very flexible.
All right. How is the overburn handled for different sized roughing and finishing electrodes?
By copying the tool path and changing the overburn per tool path.
Okay. And I see that we do have a good number of attendees hanging on, so I'll answer 2 more. Does Cimatron support 4- and 5-axis machining for reducing electrode setups?
Yeah, so I know that a lot of companies are taking advantage of like trunnion style electrode setups so that they can lay the electrode down and cut it from different orientations. And that would be considered 3+1 or 3+2 machining usually.
Mm-hmm.
And yeah, we don't charge extra for that type of programming. Well, I mean, if you wanted 4-axis simultaneous or 5-axis simultaneous, then that would be, additional software. But that would just require a custom post. So either a 4-axis or a 5-axis post would handle all of that.
Okay. We'll make this the last one. One of our audience asked, when you changed the overburn, how did that change in the procedures? And they are now re-asking it. What are you setting in the toolpath for overburn that carries to all procedures? I guess carries over to all procedures is.
Yeah, I understand. So it is the electrode. I think it's called electrode machining. Let me open Cimatron and see. Yeah, so there's an electrode machining box that you check, and upon checking that, there is a 2D orbit or a 3D orbit. And I probably should have mentioned this earlier too. We can put the violation on either as a 2D offset or a 3D offset, anticipating the same orbit. And so the edit spark gap that I showed is the 3D orbit parameter inside the electrode machining dropdown.
All right, we'll take just one more since we're almost 15 minutes past the top of the hour. On the NC programming, what is the difference between having electrode machining just selected with 0 spark gap, with a spark gap, or the box not selected at all?
Well, if the electrode box is selected, then that enables that parameter to work. You can have, in fact, that's how I used to have my template. I would have the template set with the electrode machining check, but you can leave the values out. And then when you're ready to put the overburn in, you can do it as I showed with the electrode edit spark gap. So if you put 5,000 positive value in the, looking for the wording here. If you put a positive 5,000 in the parameter called spark gap, it's essentially the same as putting minus 5,000 in the parameter called surface offset. The only difference is that if you put it in the spark gap parameter, you can then access what I showed under edit to push it into all those other procedures.
All right. Well, that does it for our time. All unanswered questions will be passed along to Cimatron E and to John, and you can expect a reply via email. The entire webinar will be available for replay starting at about 4 o'clock Eastern Time, and you and your colleagues can access it then or later by using the same sign-in link you used just a few minutes ago to join us. As John has shown, hybrid modeling, automated NC programming, and other approaches can help take the toil and trouble out of electrode design. SME and Advanced Manufacturing Media also have a host of ways to keep you in touch with other developments in manufacturing solutions and technology. For instance, the September issue of Manufacturing Engineering takes a look at how the Internet of Things is changing PLM. In our October issue, we are including our annual software special section. In addition, you can join us at the Canadian Manufacturing and Technology Show, September 28th through October 1st in Mississauga, Ontario. And you can experience live equipment demonstrations and find cost-saving solutions there, and also at FabTech 2015, which is being held November 9th through 12th in Chicago. Thanks for joining us for this Advanced Manufacturing Media webinar. We hope you found it informative.